Okay, greetings one and all, and welcome to this math video. In this math video, we'll be considering the topic geometry, concepts and rules. Yes, geometry, concepts and rules. Let's begin. Okay, the first question says that the interior angle of a regular polygon is 162 degrees. Calculate the size of each exterior angle. Okay, so first, let's consider what do we mean by interior angle and exterior angle. So exterior angle, as the name suggests, refers to angles that are on the outside, right? So on the outside of the polygon. So for example, this angle A is on the outside, angle B is on the outside, and angle is also on the outside. So they are what we call the exterior angle. Now the interior angle, as the name suggests, refers to the angles that are on the inside of a polygon. So for example, if we look at this polygon, which is a triangle, and let's call this angle E. Well, angle E is on the inside of the polygon, so we call it an interior angle. And if we call this one, let's call this one, say, angle T. All right, angle T. Angle T is also on the inside, so we call it an interior angle. And let's say if we call this one, say, angle H. Angle H is also on the inside of the polygon. So it is definitely the interior angle. So E, T, and H is the are the interior angles, and A, B, and C are the exterior angles because they are on the outside. Now, one thing to note about interior angles and exterior angles, when you add them up, the sum of the interior angle and the exterior angle is going to be equal to 180. So for example, E and C, that's an interior angle and an exterior angle. Their sum is going to be equal to 180 degrees. So if we already know that the interior angle is 162 degrees, then in order to find the exterior angle, we have to subtract. So we have to do 180 minus 162, and that's going to give us 32. And so that's why we have this subtraction. All right. So let's move on to the next question. It says that the interior angle of a regular polygon is 162 degrees. Calculate the number of sides of the polygon. And so what we want to find is we want to figure out the number of sides of this polygon, with the understanding that each of the interior angles of this polygon is 162 degrees. All right, so let's use this useful formula. This formula is going to come up several times within this video. This formula is very helpful when we're considering geometry questions. So the formula says that if we want to figure out what the interior angle of a polygon is, what we have to do is we have to say 180 times n minus 2 all over n. So if you want to figure out the interior angle of a regular polygon, you're going to say interior angle equals to 180 multiplied by n minus 2 all over n, where n is going to be the number of sides. And so we already know that the interior angle of this polygon is 162 degrees, so we put that in, and now I put it over 1 because I'm preparing to do cross multiplication, and so that's why I put it over 1, because we know that 162 is equal to 162 over 1. Those two are equal. So we have 162 over 1 equals to 180 times n minus 2 all over n. We're going to cross multiply. We multiply the n by 162, and we multiply the 1 by 180 times n minus 2. 162 times n, or n times 162, is going to be equal to 162 times n. And then 1 times 180 times n minus 2 is going to be 180 times n minus 2, because 1 times the quantity is the quantity itself. Moving right along, we say, okay, well, we still need to figure out what n is, because n is the variable that we're trying to solve. That equals to the number of sides. And so we're going to distribute. So we're going to say 180 multiplied by n and 180 multiplied by 2. 180 multiplied by n is going to be 180 n. And then 180 multiplied by 2 is going to be equal to 360. And so here we have 180 n minus 360. I do not need this bracket here. I should not put this bracket. It's just not needed. All right, so next what we do is we move the 180n all over to the next side of the equation. And so we have 162n minus 180n equals to negative 360 degrees. All right, so what does that mean? That means that we have to do the subtraction. 162 minus 180n, sorry, 162n minus 180n, and if we do the subtraction, it'll be negative 18n equals to negative 360 degrees. Okay, good. So how did we get the negative 18? Well, we got the negative 18 because we subtract 162 minus 180, sorry, 162n minus 180n. That's going to give us the negative 18n equals to negative 360. All right, now what we're going to do, we're going to divide both sides by negative 18. All right, and so this 18, negative 18 is going to cancel with that negative 18, leaving us with just n is equal to negative 360 degrees, not degrees, sorry. N is equal to negative 360 all over negative 18. And what is negative 360 divided by negative 18? That's going to be positive 20. And so that means that n is equal to 20. That means that the number of sides of this polygon, if we know that the interior angle is 162, that means that the number of sides of this polygon is going to be equal to 20. Okay, let's move on to the next question. Here we have another question. It says, find the size of the following angles. We have to figure what is the size of angle A. And a useful rule that we're going to use here is that for isosceles triangles, if we're dealing with an isosceles triangle, we know that two of the angles are going to be equal to each other. Again, if we know that we're dealing with an isosceles triangle, two of the angles are going to be equal to each other. And if we consider this triangle right here, right, this same triangle, if we notice this triangle, we notice that this is an isosceles triangle. And the reason why it's an isosceles triangle is because we see the two scrotes on this side and we see the two strokes or two lines on this side. That means that this line right here and this line right here are equal to each other. They're equal in length, all right? They are equal in length. So these two lines are equal in length. What that means is that since these two lines are equal in length, that means that this is an isosceles triangle. And so if the two sides are equal in length, that means that the two angles, right? The two angles are gonna be equal. And so that means that, well, what does that mean? Well, that means that if this is 25 degrees, that means that if we go on the other side, right here, this would also be 25 degrees. All right. And so again, if this is 25, this must also be 25 because the angles are equal. So not only are the lines equal, right, but the angles are equal. So 25 degrees is equal to 25 degrees. Both of these angles are equal. And so we also know that the angles, the sum of the interior angles in a triangle is going to be equal to 180 degrees. So that means that 25 plus 25 plus A, if we add them all together, should give us 180 degrees. But what is A? Well, in order to find A, we're going to add up 25 and 25, and that's going to give us 50. And we're going to subtract 50 from 180. And so we have 180 minus 50, which is going to give us 130 degrees. So that means that A has to be 130 degrees, because if A is 130 and this side is 25 and this side is 20, sorry, if A is 130 and this angle is 25 and this angle is 25, add them all together and you will definitely get 180. All right, so what is B? For B, we need to understand this next rule. And the rule states that for equilateral triangle, all three angles of the triangle is going to be equal to each other. So if we're dealing with an equilateral triangle, all three angles are going to be equal. And here we are definitely dealing with an equilateral triangle. And we know that because all of the sides are equal. And how do we know all of the sides are equal? Because all of them have the same double stroke. So this one has a double line on it. This one has a double line. This one has a double line, indicating that all of the lines are equal in length. And if all of the lines are equal in length for this triangle, that means that all of the angles are equal in measure. All the angles are equal in their size. And so that means that if this angle, right here is B, that means that this one is also B. That means that this one is also B. All right. We also know that angles in a triangle add up to 180 degrees. So that means that in order to figure out what B is, we're going to say 180 divided into 3 equal parts. So 180 divided by 3, and that's going to give us 60 degrees. So angle B, the answer is 60 degrees. Now, in order to get C, the first thing we have to remember is that we have to remember that angle A, right? Angle A is equal to what? 130 degrees. Okay, so let's put that there. And we have to remember that angle B is equal to what? 60 degrees. So angle A is 130 and angle B is 60 degrees. And so how are we going to figure out what is angle C? Well, the rule that we're going to use is that angles around the point, so here's this point right there, the angles around the point add up to 360 degrees. So we have this point right there where this red dot is, and the angles around it, which is going to be A, B, and C, the angles around it add up to 360 degrees. All right, look at the circular motion that I'm forming. The angles around this same point equals to or add up to 360 degrees. All right, and so that means that C plus A plus B all add up to 360 degrees. So in order to figure out what C is, well, we already know what A is, that's 130, and B is 60. So we're going to add them together. So we add 130 plus 60. And when we add 130 plus 60, so let's add that 130 plus 60, that's going to give us 190. And so now we have 360 minus 190, and that's going to give us 170. Again, 360 minus 190 is 170. So that means that C is going to be equal to 170 if we want these three to add up to 180. Sorry, if we want these three to add up to 360. So C is 170, A is 130, and B is 60, and add them all together, and you will get 360 degrees. Okay, moving right along, let's turn to the next question here. It says in the above diagram, y is equal to 2x. That's the value of y. Y is equal to 2x. Now it says find the size of the following angles. So we have to find the size of angle x. Notice here we have angle x. Angle x is right here. And so they want us to figure out how many degrees. What is the size or what is the measure of angle x? In order to do that, there's an important rule that you have to know. And the rule is for alternate angles. And so alternate angles, the way that you identify them is by, they form a Z shape. All right, they form a Z shape. And so if you look here, this angle and this angle right here are what we call alternate angles, right? Or alternate interior angles. They form a Z shape or a Z pattern. That's the way that you can identify them. Now the rule is that alternate angles are equal. So this angle right here and this angle right here, they are equal in size or equal in measure. So if we look at our diagram, do we see a Z forming anywhere? Well, of course we do, because if we look here, we have this parallel line, right? This line right here is parallel with this line, okay? Right? And then we have a transversal right here. And so if we look carefully, you can see the Z shape. So that means that this angle, which is 52 degrees, and this angle, which is X, are equal in measure. So if this is 52, then that means that X is also 52 degrees. And so that means that angle X is also 52. So if this is 52, angle X is also 52 degrees. And so that means that angle X is 52. So the reason is because alternate angles are equal. Great, now let's consider y. We know that y is equal to 2x. Now we know that x is 52 degrees, and so if y is equal to 2x or 2 times x, then that means that in order to figure out what y is, we're going to multiply 2 by 52, and 2 multiplied by 52 is definitely 104. And so what does that mean? That means that here we have, for this angle, which is y, right, we have 104 degrees. 104 degrees. And this angle is going to be very useful because we needed to figure out what z is. Sorry, we need this angle to figure out the value of z. And so for z, there's a very important rule that is helpful when finding out the value of z. Notice that this shape right here has 1, 2, 3, 4 sides. All right, it has 4 sides. And so we call it a quadrilateral. And so the rule for quadrilaterals when it comes to geometry is the following. It says that angles inside of a quadrilateral add up to 360 degrees, while the interior angles of a quadrilateral add up to 360 degrees, which means that 52 plus 118 plus this is 1 104, right? So 52 plus 118 plus 104, add them all together, and of course add z, then you get 360 degrees. And so let me just put 104 here so we can know what y is, so we can remember what y is. And so again, 52 plus 104 plus 118 plus z equals to 360 degrees according to that rule. So in order to figure what z is, all we need to do is take 360 and subtract it with 52 plus 118 plus 104. So we add what we have, the 52, the 118, the 104, we add them all together and we subtract it from 360, and that should give us what z is. And so we have 360 minus 274, and we got the 274 by adding up all of these numbers. And so 360 minus 274 is going to be, again, 360 minus 274 is going to be 86. And so that means that z is equal to 86. So if I add 52 plus 118 plus 104 plus 86, let's add them together. So 118 plus 52 plus 104 plus 86, if we add them together, we get 360 degrees precisely. Okay, let's move on to the next question. For the next question, it says, the polygon below is a regular decagon. Calculate the size of the angles. And the angle, the first angle that we need to figure out is angle X. Now they say that this is a decagon, which means that it has 10 sides. And we can count the sides of this polygon. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Indeed, it is a decagon because it has 10 sides. Now, what we need to find out is that we need to find out what is the value of X. Now, X is an interior angle, is one of the interior angles of this decagon. And so how are we going to figure out the interior angle of a decagon? Well, first, we need to use this formula. The formula states that if you want to find the interior angle of a regular polygon, you're going to take 180 and multiply it by n minus 2 all over n, where n is the number of sides. Now, the number of sides for this regular polygon is 10 because it is a decagon. And so what we're going to do is we're going to say, okay, wherever we see n, we're going to put 10. And so the interior angle is going to be equal to 180 multiplied by 10, all right, minus 2 all over 10, all right? So wherever we see n, we put 10. 10 minus 2 is going to be 8, all right? So 180 multiplied by 10 minus 2, which is 8 all over 10, and 180 multiplied by 8, again, 180 multiplied by 8, let's multiply them. 180 multiplied by 8 is going to be 1,440 all over 10. 1,440 all over 10, and let's divide that. Divide that by 10, and so that's going to be equal to 144. So that means that the interior angle of this decagon, which is X, is going to be equal to 144. And each of the interior angles inside of this decagon is going to be equal to 144. And we know that because it's a regular decagon, and so all of the angles are going to be equal to each other on the inside. Okay, let's move on to the next question. Here we see they want us to calculate the size of angle Y. Well, angle Y is an exterior angle, and we know that in order to find the exterior angle, we have to take the interior angle and subtract it with 180. Because if you look carefully, we have the interior angle here. All right, so the interior angle right here is going to be equal to 144. All right. That's the interior angle. But if we want to find out what is the exterior angle, we have to subtract that with 180 degrees. Why? Because 180, why? Because if we add the interior angle plus the exterior angle, it adds up to 180 degrees. And so in order to find out what is the size of the exterior angle, given that we already know the interior angle, we just subtract them. So 180 degrees minus 144 is going to be equal to 36. And so 36 is the size of this exterior angle. All right, moving right along, it says the polygon below is a regular decagon. Calculate the size of angle Z, Now, let me just clarify it. Angle Z is this one. right? This part right there is not really a full, it's not really a full interior angle. So it cannot be 144 because it's not like a full thing. It's not like the full, like it's not like we're looking at the full interior angle of this decagon. So it's not like we're looking at all of this. We're looking at part of the interior angle, which is Z. And so in order to do this, we're going to um, consider this rule, and this is a very important rule, especially for these questions. The rule states that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3. And so what that means is that if you want to figure out how many diagonals that come from one vertex of this of a polygon, the way that we can find out how many diagonals that comes from it is going to be we have to use the formula n minus 3. And a vertex is going to be each of these points right there. Each of these points we call a vertex, all right? And each of these vertices, right? N minus 3 diagonals can come from each of these vertices. And so we already know that n is the number of sides. And so each vertex of this decagon is going to have 10 minus 3 because 10 is the number of sides. So it's going to be 10 minus 3, which is equal to 7 diagonals. So that means that each of these vertices is going to have 7 diagonals that could come from each one of these, right? Now, I only drew the 7 diagonals for this one, right? Because that's our point of interest. And so if you look carefully, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So we have 7 diagonals. Only 7 diagonals can work for a decagon, a regular decagon. Now let's figure out what each of these angles, the measure of each of these angles here is. They're going to be equal to each other, but what is their measure? So we know that there is 1, 2, 3, 4, 5, 6, 7, 8, 8 of these spaces, and we know that the interior angle is 144. So we divide 144 by 8, and when we divide 144 by 8, we get 18. And so that means that each one of these little spaces here is going to be 18 degrees in measure. Now we know that Z accounts for 2, right? Z accounts for 2 of these 18 degrees, right? So Z accounts for 2 of these 18 degrees. And so that means that what we're going to do is we're going to multiply 18 by 2. So Z is going to be 18 plus 18, or 18 multiplied by 2. And so Z is going to be equal to 2 times 18, which is going to be 36. And so Z equals to 36 degrees. Okay, let's move on to the next question. It says, using a diagram, calculate the size of angle X. Now, if we look at angle X, there's a very important rule that we could use. Angle X is the interior angle of a triangle. And if we look carefully at the triangle itself, we notice that this triangle actually, it's actually an isosceles triangle. And remember the rule for isosceles triangle. If it is an isosceles triangle, that means that 2 of its angles are going to be equal if it's an isosceles triangle. Now, how do we know it's an isosceles triangle? It's because notice that these double strokes we have, it's on both sides of the triangle. That means that these 2 sides are equal in length, or these 2 sides are equal in measure. So this side, right, the length of this side is equal to the length of this side. They're equal. And that also means that the 2 angles at the bottom are going to be equal. And so let me label that X. It means that this is going to be equal as well. And so there we have it. And so what we have is 50x plus x, and we have 54. And if we add them all together, it's going to give us 180. So what we're going to do is we need to find out what x is. And we can do that because what we could do is we could subtract 54 from 180. And so when we do that, 180 minus 54. So let's subtract that. When we subtract that, we get 126. Now, what we have to do is we have to split 126 evenly so that x and x could have equal portions. And so 126 divided by 6 divided by 2. So we split 126 evenly because these are 2 equal angles. And so 126 divided by 2 is going to be equal to 63. What does that mean? Well, that means that this x is 63 degrees, right? That means that this x is 63 degrees. And that also means that this x right here is also 63 degrees. They are equal in measure. All right, so what is y? Well, if we look at y, the angle y right here is inside a triangle. It's the interior angle of one of, sorry, it's one of the interior angles of this triangle. And what we notice here is that this triangle also is an isosceles triangle. And so that means that the rule that we can use for isosceles triangle is that what? For isosceles triangles, two of its angles are equal. And how do we know it's an isosceles triangle? It's because notice that this have the double stroke, and a double stroke or the double dash or the double lines indicate that these two sides are equal. All right, they indicate that the two sides are equal, but more than that, they indicate that the two angles are equal. All right, the two base angles are equal. So if this is 72 degrees, what that means is that this angle right here, which is on the base of the triangle, will also be 72 degrees. All right, so this is going to be 72 degrees as well. All right, so both of the angles are equal in measure. So we have 72 plus 72 plus y is going to be equal to 180 degrees. And so in order to figure out y, all we need to do is we need to subtract 72 plus 72 from 180. And what is 72 plus 72? Well, 72 plus 72 is definitely 144. And so we're going to take 180 and we're going to minus that with 144 and we get 36. And so that means that y equals to 36 degrees. Now we need to figure out what z is, all right? And if you look carefully, z is on the same line, right? It's on the same line as x. And if we look here, we have 72 here and we have z. The rule that we're going to use here is that angles on a straight line at a common point add up to 180 degrees. Notice that angle x, angle z, and angle 72, all of them are on the same line and they are at the same common point that I have in red. The same dot that I have in red, all three of those angles are at that common point. And so if we consider angles on a straight line and at this common point, which is going to be x, 72, and z, all of them added together is going to be equal to 180 degrees. And so in order to get what z is, we're going to subtract. So we're going to say, okay, 180 degrees minus 63 plus 72. So we add the 63 and the 72 together. We add them, and then we subtract that answer from 180 degrees. So 180 minus 135, we got the 135 because we added 63 plus 72, which is 135. And so we have 180 minus 135, which is going to be equal to 45 degrees. Okay, let's move on to the next question. All right, for this one, it says the diagram below represents a regular octagon. Now for octagon, the number of sides is definitely 8, and we can count it. So it's going to be 1, 2, 3, 4, 5, 6, 7, and 8. So that's what we call an octagon because it has 8 sides. Now it's a regular octagon, which means that the angles and sides are equal in measure. So all of the angles are equal in measure and all of the sides are equal in length. Okay, so we need to figure out what is x. Now, if we look carefully, x is going to be the interior angle of this octagon. So the x is the interior angle of this octagon. And how are we going to figure out what is the value of an interior angle? Well, we use our formula, the form that we have been using. The formula states that interior angle equals to, if you want to find interior angle of a regular polygon, you're going to take 180, multiply that by n minus 2 all over n, where n equals to number of sides and n, the number of sides in this case is going to be 8. And so what do you do? What do we do? We take the interior angle that's going to be equal to 180 multiplied by 8 minus 2. Why 8 minus 2? Because the number of sides is 8, so it's going to be 8 minus 2 all over 8. And then 8 minus 2 is definitely 6. It's going to be 180 multiplied by 6 all over 8. And so what is 180 multiplied by 6? 180 multiplied by 6, that's going to be equal to 1080. It's going to be 1080 all over 8. And so we say 1080 divided by 8. Again, 1080 divided by 8 is going to be 135 degrees. So 1080 divided by 8 is going to be 135 degrees. So that means that x is equal to 135 degrees. And that's the value of the interior angle inside this octagon. Okay, moving right along, we have to find the value of y. And they said here that we need to show our working. Y is not an interior angle in the sense that it's not the complete interior angle that we found for x. X is the whole thing, right? From end to end, right? But this one it stops at a portion, all right? So it's not like it's talking about this whole section here, all right? It's just talking about a portion of the interior angle. And so if we want to figure out what our answer is, what we need to do is we need to consider this rule. And the rule says the following. The rule says that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3. So what that means is that for each of these vertices, that means that for each of these vertices, if you want to figure out how many diagonals spring forth from each of these vertices, we have to use this formula, which is n minus 3, which means that you're going to take the number of sides and you're going to subtract it by 3, and that's going to tell you how many diagonals that you're going to get from each vertex. Now, what is the size of, how many sides does this polygon have? Well, it has 8 sides, and so that means that for each of the vertex of the octagon, right? Each vertex of the octagon has 8 minus 3, which is n minus 3. 8 minus 3, which equals to 5 diagonals. That means that for each one of these vertices, right? Each one of them is going to have 5 diagonals springing forth from it. And so if you look at, I just did it for one, I didn't do it for all. If you look at this particular vertex, how many diagonals do we see coming from it? We have 1, right? We have 2, we have 3, we have 4, and we have 5, right? Those are 5 diagonals that are coming from this particular point. Now, how many spaces do we have? We have 1, 2, 3, 4, 5, and 6 spaces. So what we need to do is what we need to do in order to find the angles for each one of these, we need to take 135, which is our interior angle, right, and divide it into 6 equal parts. So 135 divided by 6, because we need to split it into 6 equal sections. This whole thing right here is an interior angle, which is equal to 135, but we need to split 135 into 6 even portions. And if we do that, we get 22.5. And so that is going to be the size of each of these little spaces here, 22.5, right? And if you do 22.5 multiplied by 1, 2, 3, 4, 5, and 6, if you do 22.5 multiplied by 6, you will get 135. Let's do that. 22.5 multiplied by 6, that gives us exactly 135. And so that means each one of these little spaces is going to be 22.5. We know that y takes up how many little spaces? Y takes up all 3 of these spaces. So y takes up this one, and that one. So y is going to be equal to 22.5 plus 22.5 plus 22.5. So y is equal to 22.5 times 3, because it's there 3 times, all right? So that's what y takes. So y takes 3 of them. It accounts for 3 of those little spaces. And so we have y is equal to 3 times 22.5. And what is 3 times 22.5? 3 times 22.5 is definitely 67.5. Okay, let's move on to the next question. So y is equal to 67.5. Okay, let's move on to the next question. It says the polygon below represents a regular octagon. And we know that for an octagon has 8 sides. It says calculate the following angles. You must show your working. And the angle that they want us to find is angle Z. Remember that for each vertex, right? Remember the formula we use for each vertex of this octagon, it can it can have 5 diagonals. It can have 5 diagonals springing forth from this particular vertex. And so let's draw in the diagonals again. And so 5 diagonals, sorry. So this is 1, this is 2, this is 3, this is 4, and this is 5. So 5 diagonals can spring forth from this one particular vertex. And that means that the interior angle is going to be split into 1, 2, 3, 4, 5, 6 even portions, which means that each one of these little portions is going to be equal to 22.5. And since each of these little portions is going to be equal to 22.5, what that means is that Z accounts for, if we look carefully here, we'll notice that Z accounts for 2 of these little spaces, 2 of them. And so that means that Z is going to be equal to 2 times 22.5. So Z is going to be equal to 2 times 22.5, and 2 times 22.5 is definitely going to be 45. Okay, let's move on to the next question. Here it says, write down and simplify an expression for the sum of the angles of triangle L, M, and N. So we have angle, so we have angle L, right? And angle L is going to be equal to 5x. We also have angle M. Angle M is equal to 68 minus x. We also have angle N, and angle N is equal to 2x plus 28. And here they say write down and simplify an expression for the sum of the angles of triangle L, M, and N. So we have to write down and simplify an expression for this. So, okay, so what we have to do is we have to basically add these up and simplify it. So we have 5x plus 2x plus 28 plus 68 minus x. And so what we need to do is we need to group our like terms. What are the like terms? We have 5x, 2x, and negative x. Again, 5x plus 2x plus and negative x. So let's group them together. Again, we group together the x's, so 5x plus 2x minus x, and then we group together the numbers, 28 plus 68. Now let's do some simplification. What is 5x plus 2x? Well, that's definitely 7x, all right? So we have 7x, let me write down everything back again, minus x plus 2 plus 28 plus 68. Now what is 7x minus x? 7x minus x, or 7x minus 1x. Well, that's going to be 6x. All right, so it's going to be 6x plus 28 plus 68. Now let's work on the numbers. 28 plus 68 is definitely going to be 96. And so that means that a simplified version or simplified expression for the sum of the angles in LMN is going to be 6x plus 96. All right. Now let's move on. It says calculate the value of x. Now in order to calculate the value of x, what we need to do is we need to form an equation. We need to form an equation so we can be able to solve for x. Now, what we do know is that the sum of the interior angles in a triangle add up to 180 degrees. And we also know that the sum of the interior angles is equal to 6x plus 96. That is the expression that we found for the sum of the interior angles. And we know that the sum of the interior angles is going to be equal to 180 degrees. And so this is the formula that equates both ideas. So what we're going to do, we need to solve for x. And the first thing that we're going to do is we're going to send the 96 over the equal sign. So let's do that. And so now we have 6x is going to be equal to 180 minus 96. All right, let's do the subtracting. 180 minus 96 is going to be 84. So how do we do that? Let's subtract. 180 minus 96 is going to be equal to 84. That's correct. Next, we have to divide both sides by 6. Dividing both sides by 6, we cancel here, we cancel there. So that means that x is going to be equal to 84 over 6. And 84 divided by 6, let's do that. 84 divided by 6 is going to be equal to 14. So that means that x is going to be equal to 14. Okay, moving right along, let's have our next question. The question says the polygon represents a regular hexagon. Calculate the size of angle x. All right. What is a hexagon? Well, a hexagon is going to be a shape that has 6 sides. And this is a regular hexagon. So that means that all sides and all angles are equal. Okay, so we have 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, and 6. And what we want to do is we want to figure out, okay, what is going to be x? An angle x is a full-on, is a full interior angle, right? All of that is x, a full interior angle. What is the formula for interior angle? Well, for an interior angle, if you want to figure what an interior angle is, it's going to be equal to 180 multiplied by n minus 2 all over n, where n is going to be equal to the number of sides of the regular polygon, but the number of sides for this regular polygon is actually equal to 6. So what that means is that wherever we see 6, sorry, wherever we see n, we're going to put 6. Wherever we see n, we're going to put 6. And so n, right, n is going to be equal to 6. And so 180 multiplied by 6 minus 2 all over 6. What is 6 minus 2? 6 minus 2 is definitely 4. And so we have 180 multiplied by 4 all over 6. What is 180 multiplied by 4? Let's do that. 180 multiplied by 4 is going to be equal to 720. That's 720 all over 6. And what is 720 divided by 6? 720 divided by 6 is definitely equal to 120. So that means that the interior angle of this regular hexagon is going to be equal to 120. Moving right along, we have another question, and the question says calculate the size of angle y. So angle y is this particular angle right here. And for this question, what we're going to do is we're going to remember our formula or our rule. The rule says that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3, which means that, and it's important to know that n equals to the number of sides. So that means that if we have a vertex, right, for each of these vertex or for each of these vertices, the number of diagonals that can originate from each of them is going to be n minus 3, where n is the number of sides of this hexagon. Now, since we know that the number of sides of the hexagon is 3, that means that each vertex of the hexagon has 6 minus 3, which equals to 3 diagonals. That means for each one of these vertices, I can draw 3 diagonals from each one of them. I'm going to choose this vertex to draw the diagonals. And the reason why I choose this vertex is because I'm interested in finding out what the value of y is. And so here we have this diagonal, that's 1, that's a diagonal, that's 2, and this other diagonal, that's 3. And so if we were to be concerned about these little spaces, right, how much or what is the value of these little spaces? What is going to be the angle for these little spaces? We know that the full interior angle, we know the full interior angle is what we got for the first time. The first interior angle is going to be 120. The full interior angle is going to be 120. But what we want to do is we want to divide 120 into 1, 2, 3, 4 equal parts. And so we're going to say 120 divided by 4, which is going to be equal to 30. And that means that each one of these little spaces here is going to be equal to 30 degrees. So this is 30, that's 30, this is also 30, and that's also 30. Now let's consider what y is. Well, y accounts for 130 and another 30. So y accounts for 2 30s. And so that means that the value of y is going to be equal to 2 times 30. And 2 times 30 is definitely 60. Okay, let's move on to the next question. Here we have angle z. We need to figure out what is the value of angle z. It says, what is the size of angle z? So what we know, right, is that we know that each one of these little spaces is going to be equal to 30 degrees. And we also know that for each vertex, we can draw 3 diagonals for this hexagon, 3 diagonals. And that each one of these little spaces is going to be equal to 30 degrees, all right? And so z accounts for this 30 and also for this 30. That's the space that z occupies. And so that means that z is, oh, no, one more. Let's check it again. Yeah, definitely. Z is equal to 3 of those 30s, all right? So z is equal to this 30 plus this 30 plus this 30, right? That full thing is z right there. And so that means that z is going to be equal to 3 times 30, which is going to be equal to 90 degrees. Okay, let's move on to the next question. Here we have this question. It says a regular polygon has 24 sides. That's a lot of sides. Calculate the size of one interior angle. So they give us the number of sides, which is 24. And what we need to do is we need to figure out what is the value of one interior angle. And so how are we going to do that? Well, interior angle is going to be equal to 180 multiplied by n minus 2 all over n, where n is the number of sides. And what do we know already? The number of sides is going to be equal to 24 sides. And so we have 180 multiplied by 24 minus 2 all over 24. We're going to do is we're going to minus 24 and 2. 24 minus 2 is definitely going to be equal to 22. And so we have 180 multiplied by 22 all over 24. Now, what is 180 multiplied by 22? Let's do the multiplication. 180 multiplied by 22 is definitely 3,960. So we have 3,960 divided by 24. And let's divide those two numbers. It's going to be 3,960 divided by 24. And that's going to be equal to 165. Which means that if we have a regular polygon that has 24 sides, each one of those interior angles is going to be equal to 165 degrees. Okay, let's move on to the next question. The question is number 24. It says that the polygon below is a regular octagon. Now, an octagon has 8 sides, and this is a regular octagon. Let's count the sides. So we have 1, 2, 3, 4, 5, 6, 7, 8. And so what that means is that if we look carefully, this is a regular octagon. That means that all of the sides and all of the angles are equal. So all of the sides are equal in length, and all of the angles are equal in measure. And so here they want us to figure out what is the size of angle X. Now angle X is definitely the interior angle, and if we look carefully right here, angle X right here, that's the interior angle. And so what we need to do is we need to figure out what is the value of that interior angle X. And here we're going to use our formula. And so the formula says that the interior angle of a regular polygon is going to be equal to 180 multiplied by n minus 2 all over n, where n is going to be equal to the number of sides. Let's go. Where n is going to be equal to the number of sides. And what is the number of sides for this octagon? It's definitely 8. So wherever we see n, we're going to put 8. And so we have interior angles are going to be equal to 180 multiplied by 8 instead of the n, 8 minus 2 all over 8. So wherever we see n, we're going to put 8. And so we say 8 minus 2. What is 8 minus 2? 8 minus 2 is definitely 6. And so we have 180 multiplied by 6 all over 8. And so we have 180 multiplied by 6, which is going to be 1,080 all over 8. So we have 1,080 divided by 8, which is going to be 135. So that means that the value of X, the value of this interior angle, is going to be equal to 135 degrees. Moving right along, we have this next question. It says, calculate the size of angle Y. Calculate the size of angle Y. In order to figure out the size of angle Y, what we're going to do is that we're going to remember our rule. The rule says that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3. And so how many sides do we have? Well, we have 8 sides. So let's apply the formula 8 minus 3 or n minus 3 because we replaced the n with 8. So 8 minus 3 is going to be equal to 5, which means that for this octagon, each vertex that I choose, I can draw 5 diagonals for each one of these vertices. Now here I only drew the 5 diagonals for this vertex. And so if we look carefully, we have 1 diagonal, 2 diagonals, 3 diagonals, 4 diagonals, and 5 diagonals. And what those 5 diagonals does is that it splits the interior angle into how much spaces? We have 1, 2, 3, 4, 5, and 6. So that means that we're going to split the interior angle of this regular octagon. We're going to split this interior angle into 6 equal parts. And so we have 135 divided by 6, which is going to be equal to 22.5. And so that means that each one of these little spaces is going to be equal to 22.5. Now, y accounts for 2 of these little spaces. And so y is going to be equal to 2 times 22.5. Y is going to be equal to 2 times 22.5, which is going to be equal to 45. And so y is equal to 2 times 22.5, which is going to be equal to 45. So y is equal to 45. Moving right along, let's consider this question. It says, calculate the value of angle S. Calculate the value of angle S. Angle S is right here. And if you notice carefully, we have angle S. It's on a straight line along with 63. And both 63, or both the angle that measures 63 degrees and angle S is at the same common point. So both of them are on that straight line and are at that same common point denoted in red. And so that means that this is perfect for us to apply our rule. And the rule says, did I have the rule? No, I didn't put the rule up. But the rule says that angles on a straight line that are at a common point add up to 180 degrees. So angles on a straight line at a common point add up to 180 degrees, which means that 63 and S is supposed to be equal to 180 degrees. And so in order to figure out what S is, we already know what this one is. So it's going to be 180 minus 63, which is going to be equal to 117. And if we add 63 plus 117, so let's add that 63 plus 117, that's definitely equal to 180 degrees. So S is going to be equal to 117. Okay, let's move on to the next question. This one says we're going to figure out what angle T is. Okay, and in order to figure out what angle T is, we're going to use this rule. And the rule says for any polygon, regular or irregular, the sum of all the exterior angles is always 360 degrees. Now, the exterior angles are going to be the angles that are on the outside. And so if we look carefully, we have, this is an exterior angle, which is going to be 49. 63 is an exterior angle because it's on the outside. 71 is an exterior angle. T is an exterior angle. And we also have this one. This is also an exterior angle. And let's see what it is. If this is 90, right? If this one is 90, right? This must also be 90. And the reason why is because 90 plus 90 gives us 180 degrees. And so let me draw the box properly. And so erase our link. So if this is 90 on the inside, all right, this one is automatically going to be 90 again, because they're on a straight line. They are at a common point, and angles on a straight line at a common point must add up to 180 degrees. So this is going to be 90. All right, 90. What I meant to draw is an actual box. So let me try my hand again at drawing the box. And so let's go. So what we're gonna do is draw it out. Okay, and draw it down. Okay, so this is 90. All right, this angle right there is 90, and this angle right there is also 90. So what does that mean? That means that we have 63 as an exterior angle, 90 as an exterior angle, 49 as an exterior angle, T as an exterior angle, and 71. So 90 plus 49 plus 63 plus T plus 71, again, 90 plus 49 plus T plus 71 plus 63 should add up to 360 degrees. So in order to figure out what T is, we're going to add up 63, 90, 49, 71, add them all together and subtract our result from 360. And so let's do that. So 360 minus 49 plus 71 plus 63 plus 90. Again, we have 49 plus 71 plus 63 plus 90. Right, that's going to be equal to 273. So we have 360 minus 273, and let's subtract 360 minus 273. That's going to be equal to 87. And so that means that T equals to 87. Okay, let's move on to the next question. It says that a regular polygon has interior angles of 165 degrees. Calculate the number of sides of the polygon. And so here we need to figure out the number of sides, And so for this one, we already know though that its interior angle is going to be 165 degrees. Here we're going to use a very useful formula. The formula says interior angle is equal to 180 multiplied by n minus 2 all over n, where n is going to be the number of sides. Now, for this one, let's substitute. So we already know that we have 165 here. So for the interior angle is going to be 165. So let's substitute that for 165. I put 165 over 1 because 165 is the same thing as 165 all over 1. And The reason is because a quantity divided by 1 is still the quantity itself. And I also put it over 1 because I'm preparing to do cross multiplication. Now we're going to multiply n by 165. So n times 165, n times 165. And we're also going to multiply 1 by 180 multiplied by n minus 2. What is n times 165? Well, that's going to be 165n. Again, n times 165 is going to be 165n. And then 1 times 180 multiplied by n minus 2 is going to be 180 times 1 times n minus 2. Again, 1 times 180 times n minus 2 is going to be 180 times n minus 2. Why? Because 1 times a quantity, right? 1 times the quantity, any quantity, is the quantity itself, because 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, all right? And so 1 times 180 times n minus 2 is going to be equal to 180 times n minus 2. So now we have this equation, but without any denominators. And so what we're going to do is we're going to distribute. So we have 180 multiplied by n, and we have 180 multiplied by 2. So let's distribute. That's going to give us 180 n, and it's going to be 180 multiplied by 2. And so we have 180 n minus 360. So what we're going to do, we're going to send the 180 n over the equal sign. So we have 165 minus, it was positive here, so when we send it over, it becomes a minus. So it's going to be 165 n minus 180 n, which is going to be equal to negative 360. All right, let's subtract. So we have 165 n minus 180 n, which is going to be equal to negative 360 degrees. Sorry, not degrees, negative 360. So we have negative 15 n negative 15 n equals to negative 360. Now we need to get rid of that negative 15 because, well, we want n by itself. So we're going to divide both sides by negative 15. These two 15s are going to cancel out along with their negative sign. So negative 15 cancel negative 15. So we're going to be equal to n equals to negative 360 divided by negative 15. And so n is going to be equal to 24, which means that the number of sides of this polygon, provided that we know that its interior angle is equal to 165, is going to be equal to 24 sides. All right. Okay, let's move on to the next question. The next question says the following. Each interior angle of a regular polygon is 162 degrees. Calculate the size of each exterior angle. Now, this question we did before. It came in 2023 and also came in 2011. So it's the same question. So calculate the size of each interior angle. So in order to find the size of each interior angle, we know that each interior angle is going to be the ones that are on the outside, and the interior angles are going to be the one on the inside. We also know that the sum of the interior angle and exterior angle is going to be equal to 180 degrees. And so that means that if I want to figure out the size of an exterior angle, given my interior angle, I'm going to subtract the interior angle with 180. And so 180 minus 162 is going to be equal to 18 degrees. Let's move on to the next question. It says each interior angle of a regular polygon is equal to 162 degrees. Calculate the number of sides of this polygon. All right, we did this before. What we have to do is we have to replace in the interior angle with 162. And so that's going to be 162 over n. And we need to remember what that n is going to be equal to what? N is going to be equal to, well, they didn't tell us what n is. Yeah, they didn't tell us what n is. The only thing we need to do is substitute the interior angle. Now, what we can do here, we can cross multiply. So n times 162 and 1 times 180 times n minus 2. N times 162 is going to be 162n. And 1 times 180 times n minus 2 is going to be 180 times n minus 2. What we're going to do at this point is distribute. So 180 multiplied by n is going to be 180n. And 180 multiplied by 2 is going to be equal to 360. So we're gonna send the 180n all over the equal sign. So what that's gonna be equal to 162 minus, sorry, 162n minus 180n equals to negative 360. Again, I'm not supposed to have this bracket here. All right, let's subtract 162 minus 180n. 162n multiplied, sorry, 162n minus 180n is equal to negative 360. And so what we're going to do is when we subtract them, we get negative 18n equals to negative 360. Now, what we have to do, we have to solve for n. So if we notice carefully that negative 18 is the only number that's on the side of n, so we need to get rid of it. Let's divide both sides by negative 18. Cancel, cancel. So that means that n is going to be equal to negative 360 all over negative 18. And if when we do the division, it's going to be equal to 20. So n is going to be equal to 20. Well, let's move on to the number of sides is going to be definitely 20. But let's move on to the next question here. It says, calculate the values of the angles. So we need to figure what is the value of P. We need to figure out, and we need to figure what is the value of Q. All right, so let's consider P. Well, P is pretty easy because if we look carefully, they are already on a straight line, right? They're already at a straight line at a common point. So all we need to do is subtract from 180 degrees. So P is going to be equal to 180 degrees minus 85. So what is 180 degrees minus 85? Let's do that. 180 minus 85. That's going to be equal to 95. And so that's what we have. 180 minus 85 is equal to 95. Now let's move on to Q. So Q is going to be equal to, well, Q is, remember for this one, for a double I, it says that for any polygon, regular, irregular, the sum of all the exterior angles is always equal to 360 degrees. And so if we look carefully, how many exterior angles do we have? We have 45, that's 1, 60, that's 2, 50, that's 3, 85, that's 4, and then Q, that's also an exterior angle, so that makes the fifth one. So 1, 2, 3, 4, and 5. All right, so what does that mean? Well, that means that we have to do some addition first. So we have to add 45 plus 60 plus 50 plus 85, add all them together, and then subtract the result from 360 degrees, which is going to be 360 minus 240, which is going to be equal to 120. Okay, let's move on to the next question. Here it says that a regular polygon has 20 sides. Calculate the size of an interior angle. So in order to do this, we have to use the formula. And the formula states that an interior angle is going to be equal to 180 multiplied by n minus 2 all over n, where n is the number of sides. They already tell you that the number of sides for this polygon is definitely 20. And so what we're going to do is we're going to replace n with where we see 20. And so it's going to be 180 multiplied by 20 minus 2 all over 20. Let's subtract. So we have 20 multiplied by 2. 20 multiplied by 2. Okay, 20 multiplied by, sorry, not by 2. We have 20 minus 2, not multiplied. So 20 minus 2 is going to be 18. And so 180 multiplied by 18 is going to be equal to 3,240 all over 20. So what did we do here exactly? Well, I substitute 20 for n, so it's going to be 20 minus 2. 20 minus 2 is going to be 18. So let's do it. 20 minus 2 is going to be 18. So we have 18 at the bottom. So we have 180 multiplied by 18. 180 multiplied by 18. And so it's going to be 3,240 all over 20. All right, so let's move on. So it's going to be 3,240 divided by 20. Divided by 20. It's going to be equal to 162. So if we know that the number of sides is 20, then we know that the interior angle is going to be equal to 162 degrees. Okay, let's move on to the next question. Okay, so for this question, it says that the polygon below is a regular pentagon. Calculate the size of the angle. Now, a pentagon has 5 sides. And so let's count the number of sides for this. It's going to be equal to 1, 2, 3, 4, and 5. That's going to be equal to, that's the size of the angle. Okay, so let's move on. So what we have, we need to figure out what angle x is. Angle x is going to be this angle right there. All right, that's angle x. And so in order to find angle X as an interior angle, we need to use this formula. And the formula tells us that in order to find the interior angle, what we need to do is we need to determine n. Now, n is going to be equal to 5 because n is the number of sides. And so we need to do 180 multiplied by n minus 2 all over n. The first thing we want to do is we want to substitute for n. So wherever we see n, we put 5. So we put 5 here, put 5 here. And then we say 5 minus 2. Well, 5 minus 2 is definitely 3. And so we have 180 multiplied by 3 all over 5. And so 180 multiplied by 3 is going to be equal to 540. All right, that's 540 all over 5. So 540 divided by 5 is going to be 108, which means that the interior angle of this pentagon is going to be equal to 108 degrees. So x is going to be equal to 108 degrees. Okay, moving right along, we have this next question. It says calculate the value or calculate the size of angle y. Now, angle y is this one, this angle right here. And for this question, we're going to be using this rule. The rule says that for a regular polygon, the number of diagonals that originate from a single vertex is n minus 3. And so we know that for this one, n is going to be equal to 5 because n is the number of sides. And the number of sides for this pentagon is definitely 5. So it's going to be 5 minus 3. And 5 minus 3 is definitely equal to 2. And so that means that for each of these vertices of this pentagon, this one, this one, this one, this one, and this one, for each of these vertices, 2 diagonals. It is possible to draw 2 diagonals at most, 2 diagonals for each vertex. So we're going to draw this diagonal, right there. We're going to draw this diagonal. Now, how many spaces do we have in between? We have 1, 2, and 3. And so that means that we're going to take the interior angle, which we know to be 108, and we're going to divide it by 3. So we're going to split it evenly. And so it's going to be 36, 36, and 36. So what that means is that this is 36. So from here to here, right, that's 36. And then from in the middle, that's 36. And then from here, that's 36. And so we know that y is equal to 1 times 36, which is equal to 36, because y only accounts for one of the 36s, not all 3, just one that we need. And so y is equal to 36. Moving right along, we have angle, size of angle z. We're going to use the same concept. That's 36, that's 36. All right, we have this vertex. We only could draw 2 diagonals from it. And we know that each of these small little spaces is going to be 36 degrees. And if we want to figure out the size of angle z, what we need to do is we need to consider that z accounts for 2 of the 36s. So this 36 along with this 36. And so that means that we're going to multiply 2 times 36. And 2 times 36 is definitely going to be 72. All right, and that's the answer for z. We multiply 2 by 36. Okay, let's move on to the next question. This one is taken from 2000. It says, find the value of angle x. Find the value of angle x. Now, in order to find the value of angle x, we need to use this important formula. And this is what we call corresponding angles. And corresponding angles, they are equal to each other. And you can spot a corresponding angle because they form an F. If you look carefully, this is an F sign, right? And if you look carefully, this one is also an F sign, right? So how are we going to find the value of F? Well, sorry, the value of X. Well, let's draw out the F inside of our diagram. So let's draw it. So it's right here at the bottom here. Okay. And over on the side here. That means that F. So that means that that's F. So what else we have? We have corresponding angles. So if we have an angle here, which is X, and we have an angle here, which is X, then we can say that both of them are equal because we're using that the fact that they are corresponding angles. So that means that x is going to be equal to 84 degrees. That's what x is. X is equal to 84. All right, moving right along. So the reason is because corresponding angles are equal. All right, moving right along, we have y, right? Y is equal to, well, for this one, if this is an alternate interior angle or alternate angle, and we know that alternate angles, they form a Z shape. And so if we look here, we have the Z, all right? It's a Z shape. And we know that alternate interior angles or alternate angles are equal to each other. They are equal. They not only form a Z, but they are equal to each other. And so what that means is that if we can find the Z, then we can find what number to equate it with. And so this right here is one part. This right here is another part. This right here is another part. So let me erase that properly so you get a clear vision. So we're trying to see if we could figure out, where the Z is. So this right here is the beginning part of the Z. All right, this right here comes down. And this right here comes this way. All right, so that means that that means that Y and 63 are equal in measure. All right, because alternate angles are equal. So if that one is 63, then this one, Y, is 63 as well. Okay, let's move on to the next question. So the reason is because alternate angles are always equal. Okay, let's move on to the next question. Here we have to find the value of R. Okay, we have to find the value of R. Notice here that this side, right, is equal to this side. And the reason why we know that they are equal is because both of them have the dashes, the double dashes, to indicate that we are equal. All right, so we know that they are both equal. Now, what we need to do is we need to find the value of R. We need to find the value of R. Now, in order to find the value of R, what we need to do is we need to, okay, remember this formula. Not formula, but remember this rule. The rule is that isosceles triangle, for isosceles triangle, two angles are always equal. That's the rule. So if we're dealing with an isosceles triangle, we know that at least two of them are equal. Now, this is R, and this is also the side. This is also the side that is equal to the next side. And so both of these sides are equal in measure, in length for the triangle. And so that means that is also going to be R. So we have two R's. So basically we have 120, and we have, sorry, not 120, 110, and we have this open space here. Like, what is this? All right, and then we have R and R. So how are we going to figure this out? Well, the first thing we're going to do is we're going to multiply, not multiply, we're going to subtract. Yeah, that's subtract. So we're going to take 180 minus it by 110. So 180 multiplied by, 180 minus 110. What is that? 180 minus 110. 180 minus 110. That's going to be equal to 70 degrees. And so Q is equal to 70 degrees. That's what Q is. But we need to figure out what R is, right? And so R is going to be equal to 180 minus 70 all over 2. So we divided by 2 because we want to split the fraction evenly. So this is R, this is R. And so it's going to be equal to 110 divided by 2, 110 divided by 2, which is going to be equal to 55. So that means that, what that means is that this is 55 right now. This is 55 right now. And this one right here is 55. All right, good. And so let's move on to the next question. Okay, so the next question says the following. We have triangle XYZ. Calculate the value of I, which is angle X, Y, Z. Now, when we have Y in the middle like this, they mean that this is the angle that we need to focus on. And X, Y, Z just refers to the triangle X, Y, and Z. And so what we need to do is we need to consider what is this value of Y. Well, but the first thing we notice is that this have one stroke and this have one stroke, which means that the two lines are equal. And if the two lines are equal, that means that the two angles are equal. Let's first figure out what this one is, this angle right there, right? Let's first figure out what this angle is. And so let me see how I did this. 50. Okay, let's see what I did. Angle XYZ. Okay, I did it wrong. Okay, so I did it wrong. This is not right. Let me move this. So notice that the angle that we're trying to find is this angle, angle Y, because it say in triangle XYZ, calculate the value of angle Y. That's what we want, angle Y. And so if we want to figure out what angle Y is, we need to figure out, like, what is this angle? Like, what is this one? Well, if we could get what this angle is, then we can get what this angle is because they are equal. So let's call this one M. All right, that's angle M. You know what? Let me just call it by its name, Z. All right. So let me use M. Let me use M. So let's say, because I'm referring to the interior angle there. So let's say that if you're trying to figure out what M is, right? M is going to be equal to 180, right? 180 minus, right? Minus 130. And the reason why I know that I have to subtract it from 180 is because angles on a straight line at a common point add up to 180 degrees. And so 180 minus 130. So let's subtract that. 180 minus 130 is going to be equal to 50. So that means that M right here, right, is 50 degrees, right? That's 50 degrees. Now that's good because if we know what this is, since we know that this is 50, right? We know that this is also going to be 50 degrees, okay? So 50 plus 50, that's what angle M is, and that's what angle Y is, 50. We don't know what X is yet, but we know that this is 50 and this is also 50. So Y, okay, so Y is going to be equal to, oh, I see what I did. I didn't do it wrong. I had the right answer. Y is equal to 180 minus 130. Okay, I see what I did. So I was right. So again, Y is equal to 180 minus 30, which is going to be 50. The reason why that's the case is because what I first did was I figured out what is this one. This is 50. And I got that because I subtract what? 180 minus 130, which is going to be 50. And because we already know that whatever this one is also, so it's going to be Y is equal to 50 degrees. And I got that 50 because I got the 50 from on this side, and I got the 50 on this side because I subtracted 180 and 130 to get 50. Okay, let's move on to the next question. We already know that this is 50 and that is 50. We already know that. And so we need to figure what this angle is. All right. It's important to note that angles in a triangle. It's important to note that angles in a triangle, add up to 180 degrees. So 50 plus the one on top equals to 180 degrees. And so what that means is that we need to say 180 minus 50 plus 50. And what is 180 minus 50 plus 50? Well, 50 plus 50 is 100. And so 180 minus 100 is going to be equal to 80 degrees. And so that means that X, this angle here, right? This angle here, because that's the one they're talking about. In the middle, it's in the middle. They say Y, X, Z. So here they're talking about the one in the middle. So 180 minus 100 is going to be equal to 80 degrees. So x is going to be equal to 80 degrees. Okay, that brings us to the end of this lesson. Thank you for watching, and I'll see you in the next video.